Maybe. All right, this is writing ratios and proportions. So, John, what do you know about a ratio or a proportion? What about a rate? Oh, come on, you know a rate.
I do. I know rate and ratio.
Rate and ratio, they're pretty similar, right? Is that what you're saying? Do you know a rate? Did you get in the car this morning? Did it drive here? Was it, so it was moving.
No, your car just, it was parked.
So like, it was moving?
It was driving.
Yeah, what is that called? Rate of speed. Wow. Hey, something about I know, but yeah, no. So a rate of speed is a rate. Okay, it's kind of like
I just said rate.
it's kind of like a ratio. Okay. Okay, there's ones we use all the time, like a unit rate when you go out and buy stuff. Okay, there'll be like a unit rate. If you go to like Home Depot and you buy something, okay, they're like, oh, like for one, it's like this much, but if you buy 10, we're gonna give you like a cheaper rate because they're gonna make more. All right, there's a ratio. Okay, let's see if we can figure it out. Okay, I'm gonna give it to you. 5 to 4. What am I talking about? That's a ratio. 5 to 4. 5 to 5. My bad. 5 to 5. What is that?
Like 5.5.
No, it's in this room. 5 to 5. Oh, okay, 5 to 4. What am I thinking? 5 to 4.
4 girls, 5 guys.
4 girls, 5 guys.
Oh, I thought you meant like.
Yeah, 5 to 4. So 5 to 4 would be 5 guys, 4 girls. Make sense? Make sense? That's a ratio. How about this? 2 to 7. What's that one? 2 to 7. That just seems like a poor life choice. But that is correct. It's not the one I was thinking of.
Very good.
But there are
Pretty good.
2 wearing short sleeves and 7 wearing long sleeves. Is there another 2 to 7?
There's gotta be. I was gonna say shorts, but this is the whole. The 2 of us have long hair.
Thank you for the moment.
7 of them have.
2
2 teachers, 7.
2 teachers, 7 students. Make sense? So ratios compare like 2 things, right? So here we go. A ratio uses blank to compare 2 quantities. Division, okay, or a colon. We'll talk about this. Louis, got that? The ratio of 2 quantities, A and B, where B is not equal to 0, okay, can be written in 3 different ways. First one, A to B. It's used with the word to. I'm comparing 2 things. You okay there, Tyler?
2.
The middle way, A to B. Okay? Or the last one, A to B. Those are the 3 ways we talk about ratios. The word to, division, and a colon. Now, I don't use the word to too much, okay? That's typically reserved for like the problems. like number 1. See the word 2? When you write it out, that's how you do it. When I read them, it's all read A to B, A to B, A to B. My answers are going to be typically in these 2 formats. Got it? So, Sean and Myra are selling tickets to their school's talent show. Sean sold 34 tickets and Myra sold 44 tickets. Find the specified ratio. The number of tickets Sean sold, so Sean sold 36 to 44. You guys see how I did that? 36 to 44. Can somebody else give me a equivalent ratio?
44 to 36.
No, because that reverses it. That would tell me Myra's tickets to Sean's. So you got to keep it in this order.
36.
What if I said this? Or 18 to 22. How did I get to that?
Divided.
I divided, it's half. Divided by 2 and it's half, right? Is there another one? Or 9 to 11. Now, why are these like important things to know? Okay. Well, let's just say Louie and I, all right, we work making widgets. That's what they use all the time in math. Let's just say Louie and I assemble watches. Okay. You okay with that, Louie? So Louie and I assemble watches. Louie can assemble 9 watches in an hour, and I can assemble 11 watches in an hour. Okay? What that allows me to do, if I know how many I can do in an hour, right, then my boss, Maddie, can use that and be like, oh, in 5 hours, okay, Louie should make 45 watches, while Mr. Harmon makes 55 watches. Why might she want to know that? Well, yeah, to see who's the better worker, or if her workers are remaining on task. Let's be honest, Louie. Would you probably stay on task for 5 hours?
Doing the same
Assembling
thing
watches?
with a watch, probably not.
Probably not. So if Louie's supposed to have made 45 watches in the day and he makes 25 watches, Maddie's going to be like, come into the office, Louie. We got to talk about this. Okay? So that's where the ratio comes into play. Okay? The number of tickets Myra sold, well, we know that is 44, to the number of tickets Sean and Myra sold. Well, how many tickets were sold? How'd you get 80? Out of them. So 44 to 80. And I could reduce that to 22 over 40, which could be reduced to 11 over 20. Now, why might I want to know this stuff? Well, again, if Maddie's looking at stuff, Maddie can say, hey, Mr. Harmon is making more than half the watches. How do you know that? Well, 11 out of 20, I'm making more than half the watches. Make sense? Got it? All right, these are all ratios. Ratios typically compare 2 things that are similar, okay? For example, boys to girls, that's a ratio. They're both talking about people. In this case, Sean's tickets, Myra's tickets, they're both tickets. All right? Classrooms to a building. They're both talking about rooms. The other thing I was talking about that we started out the class was a rate. What makes a rate and a ratio different? Well, a rate's compared to things that are not similar in terms of speed. What is speed measured in? Maddie, have you ever been speeding? You have? Pretty fun? All right. Well, good thing this is going on YouTube. All right. Don't tell anybody to watch this, okay? So you were speeding, right? What are the things that speed is measured? Miles per hour. Notice miles and hours. Miles is a distance, hours is a time, right? Now, Mrs. Simonian, this is where such a benefit having Mrs. Simonian in the class. Mrs. Simonian, you do a lot of shopping, right? You do? Now, what do you always look out for when you go shopping? Like, say, at the supermarket.
Oh, I look to see the price per ounce or.
That's a
Rate.
That's a rate because it's a unit rate. Why is it a unit rate? Well, the denominator's 1, Chucky. Okay, denominator's 1. But Ellie, more importantly, a unit rate is important so that you know if you are getting a good deal on something. Now, when Mrs. Simonian goes, sometimes you shop. Do you shop at Costco? Yes. Mrs. Simonian shops at Costco. Sometimes she buys in bulk. Now, yes, she's going to spend more. What do you typically buy at Costco?
Water.
Water?
Toilet paper.
Toilet paper. Let's talk about toilet paper because that's a hot commodity right now, right? Oh, it still is.
Back to being a hot commodity.
It still is. There's a limit on it. So, Ellie, toilet paper is a hot commodity. Now, when you go to Costco, you might spend, what is it? How much is it for a big pack? Like $24 for a big pack? You might spend $24 for a big pack. But when you break that down and you do your price divided by your rolls, you're going to get price per roll. That's a unit rate. And if you go to like CVS and buy it, and you get like a little 6-pack, you do the price divided by roll. And you see which one is actually cheaper per roll. Does that make sense to all you guys? See how this all plays in together? All right, so let's keep talking about these. Let's talk about the CDs here. First off, this is a ratio because it's talking about CDs, okay? Derek's CDs and his brother's CDs, okay? You okay with that, Amy? Okay. Derek and his brother decide to combine their CD collection. Derek has 44 and his brother has 52. First thing I like to do is this. How many total CDs do I have? How do I find that? Add them. So let's add them. 96. Now, before I do anything, I typically do that. Why? Because when I do that, Mike, I already know the total, how much there should be in all. Now, these questions may ask for it or may not, but I'd rather have that piece of information at the start than get into the problem and not realize I don't have it and have to find it. Ready, Mike? Good talk, Mike.
Yes, I
Mike.
am.
Mike, how many CDs does Derek have?
He has 44 CDs and his brother has 52.
And how many does his brother have?
52.
Right. So 44 or 52?
Yep.
Okay. Now, can we reduce that?
I believe you can make it. Ooh.
What can that be reduced to?
See that? I don't know how. 52 is a trick. Maybe you could do 26.
It is 26. 22 over 26. Can we reduce that?
Oh, well, I believe so. Could you do 11 over 13?
You can. 11 over 13. All right. Shayna. The mic doesn't work. Joey.
Yeah.
Joe, how many CDs does Derek have?
He would have 11 13s.
Now, how many does he have? Read the problem. How many CDs does Derek have?
Derek has 44 and his brother has 52.
Okay, thank you. Derek has 44. How many are there in total in the entire collection? Joe?
So what would you do? Just
It's on the board. Did you read it?
yeah.
All right, how many are in total?
96.
Very good, 96. So I write 44 over 96, and I can reduce that, right? So that reduces to 22 over, what was it? Who said it? 48. Which reduces to 11 over 24. So there we go. Now proportion, we'll set two ratios or rates equal to each other, okay? Kind of think of the percent problems we were doing yesterday, right? Is over of equals percent over 100. You set the two things equal to each other. So A over B equals C over D. And what this is saying is this. AD equals BC. So here's how we do it. Ready, Kimmy? N times 25, 25N equals 5 times 45. That's 2. I know. Do you see what's happening? $2.25. And now we can divide by 25. And we get N equals 9. You okay with that? Oh, all right, Chucky. This one has a lot of stuff going on, right? You're like, how do you do it? It's different. It's not. It's the same. Watch this. 6 times B minus 2. You see that? Watch this. Equals 3 times B. I think your pencil broke. Yeah, he doesn't know your pencils.
You should get the chemical pencils. They work.
I'm gonna spend that extra $5.
All right. So we're going to distribute that 6 inside. So we have 6B minus 6 equals 3B.
6B minus what, Herman? 6B minus what,
Oh,
Herman?
sorry, 12. Whoop. 6b minus 12. Now, from here, Louis, I'm going to get all the b's to one side.
Divide by 6.
I'm going to subtract 6.
Subtract 6.
So I have negative 12 equals negative 3b. Then I divide everything by negative 3. And I get b equals 4. Whew. Is it getting warmer? Debatable. You're in shorts and the shirt's Look, listen, instant awesome. Kill me.
Where is Nate?
I don't know. All right, this is why we use them. This is all I want to get done, these two. Why do we use proportions, ratios, and rates? I told you rates are used all the time. Speed, pricing, all that stuff. Unit rates, very important. Okay, just like the percents. I told you percents are very important. Proportions are also very important. When it's not important, Chucky, I will tell you it's not important. Okay? But in like everyday life, this is important. Why? Well, guess what? What holiday is coming up? Thanksgiving. Christmas too. No, it's all good. Christmas too is coming up. Now, do you know what happens at Thanksgiving and Christmas? People come over, right? And you bake. You make cookies, you make stuffing, you make potatoes, all of this stuff, but they're all a product of a recipe, right? Now, has anybody in here made cookies? Mrs. Simonian, you better raise your hand. Mrs. Simonian? Yeah, you guys ever make cookies? You make cookies. You burn them? That's okay, you bake them. Okay? Now, we all know about making cookies. Well, you follow a recipe, right? Well, what happens when your recipe says, oh, I'll make 12 cookies, but you actually need to make 24 cookies? You double it. Well, how do you know? What if it wasn't double? What if I said, oh, man, like I need to make 18 cookies, but my recipe calls for 12 cookies? That's the best answer I heard today. But sometimes that's not going to cut it. Okay? Let's say we went with the other way, right? Let's say your recipe was for 24 cookies, but you only need 12. Well, Andy's going to go, cut it in half. Right? But we can use a proportion to figure this out. Here's one about a pool. Does anybody have a pool here? I don't have a pool. I wish I had a pool. Anybody at home have a pool?
My grandparents have a pool.
All right, awesome. Mike's grandparents have a pool, but every year you kind of have to empty it. All right, so an empty swimming pool is being filled. So in the spring, Mike's going to have to fill that swimming pool. After 5 minutes, the pool has 400 gallons of water in it. Well, if you know the pool holds 11,200 gallons, how long will it take to fill? This is a valuable question. Mike's got things to do. He ain't going to watch the pool the entire day. Or maybe he will. I don't know. Whatever floats Mike's boat. Okay? So how can I estimate this? Well, 5 minutes over 400 gallons. Everybody see that? Equals. We're after the time, right? It says how long. So X minutes over 11,200 gallons. We'll definitely need to use a calculator. But don't tell me the answer. Let me see if I can do it. So I'm going to do 5 times 11,200 equals 400x. Maddie, do you see where I got that from? Ali, do you see where I got that from?
This is hard.
I know, but do you see where I got it from?
Yeah.
You see where I got the 5 over 400 equals the x over 11,200?
Yeah.
You see where I cross multiplied and I did 5 times 11,200 equals 400 times x?
Yeah.
Okay. Now, I multiply these out and I get 56,000 equals 400x. All right so far? Now, don't tell me the answer. Now, to get my answer, I must divide by 400. So x equals, let's see, 1, 4, 0. All right, 140. Didn't you do it?
The answer was right. I didn't trust my calculation.
All right, do 5,000 or 5 times 11,200.
Yeah, that's what I.
Divided by 400. 140. Now, that's in minutes, right? How long is 140 minutes? I need to know, do I have time to go to town and country and get breakfast before my pool overflows? What? 2.5 hours. How do we get 2.5 hours? Well, there's 60 minutes in an hour. Right? So I divide it. And you get 2 hours. And now Kimmy's saying, well,
2 hours.
2 hours and 20 minutes. So thanks, Kim, for catching that. So it takes about 2 hours and 20 minutes. Or in the world of Tyler, about 2.5 hours. Right? Do I have time to do the next one? Well, I don't think I have time for that. All right. We'll pick up with this tomorrow. I will post